Alright, in this video we'll be doing classwork 3.2, number 14 with the Ferris wheel. So it says, how many revolutions per minute? So revolutions per minute, which again, remember that this is a frequency measurement, okay? Would a 15-meter diameter, so we're talking 15-meter diameter, so we're going to change that to a radius, right? We want half the arc, so it's going to be 7.5 meter radius, okay, need to make for the passengers to feel weightless at the top position, okay? So again, if we were to draw the Ferris wheel, okay, up here at the top, you are sitting in this orientation, so you have your weight acting down, and you have your normal force acting up, and that is what's causing you to turn. So this is more like the hill problem of the car racing over the top of the hill rather than in a roller coaster where you're upside down. Okay? Now, when you feel weightless, remember that normal force is your perception of your own weight. Okay? So in this case, it would be just when Fg is equal to mv squared over r. You'd have zero normal force. So you'd have zero sense of your own weight. Okay? So we have R, we have Fg equals mg, so mg equals mv squared over r, so our m's cancel, okay? And so we could very easily figure out the velocity, but the question asks us revolutions per minute. So let's go ahead and get our velocity first, and then we can figure out the how it relates to frequency, okay? So I'm going to have 10 is equal to v squared over 7.5. Okay, so the square root of 75 gives me 8.6 meters per second. So the velocity is 8.6 meters per second. Okay, but what we really want is we want to know how many revolutions we go every minute. So we're given meters every second, but we want revolutions every minute. Okay, so what I really want to know is if you can go 8.6 meters per second, what fraction of a revolution is that? Okay, so what fraction is 8.6 meters of one revolution? So we need to figure out the circumference, right? So the circumference is 2 pi r, so I'm just going to take, where's pi here? Pi times 2 times 7.5. So the circumference is 47 meters. Okay? So that means in 1 second, you're going to go, as you revolve around this thing, 8.6 meters. So if this whole thing is 47, in 1 second, you're going to do like this. So what fraction of 0.86 is that? And they'll tell you how many revolutions. So we're going to take 8.6 and divide it by 47, and that gives us 0.18 revolutions. So I can only go 0.18 revolutions in a second. Okay? Let me zoom out a little bit. Okay, so I can only go 0.18 of the way around this circle in every second. But it's asked revolutions per minute. Okay? So we're going to have to multiply this number by 60 to get it into minutes. So 0.18 times 60 gives us 10.8 revolutions every minute to make you feel weightless. Now that's a lot of revolutions if you think in 60 seconds you go around a Ferris wheel almost 11 times. That seems pretty fast and pretty scary to me. Okay, now one thing I just want to point out is the idea of frequency and revolutions and relating it to velocity. Okay, we learned that we can figure out velocity by taking 2 pi r f. Okay, but I always like to use my common sense to solve these problems because I understand circles, I understand circle math, I know what this means, and by the end of this semester, I'm going to have so many equations to memorize that if I have a way of figuring it out or knowing the answer without having to memorize an equation, it's going to save me a little bit of time, a little bit of brain space. So with circle problems, I always try to calculate them using my common sense and stuff that I already know, rather than trying to memorize like the velocity, angular velocity equations, and how to relate circumference to frequency and all that.